because this book talks about circles as they randomly get thrown in with other sections, and you didn't do circles in Algebra 2, which means it's been since geometry since you talked about circles. And I just want to remind you of the equation. So remember that if you have a circle of radius r, and its center is hk, and it passes through any given point xy, that there is a form of that equation. And it's actually not a bad thing to work with. And when we'll do conics way next semester. That'll be like the very last chapter that we do. We'll talk about circles again then. But the basic equation is x minus h squared plus y minus k squared equals r squared. And maybe what you remember even more is if the center were at 0, 0, think about h and k would be 0, and that's going to make a lot simpler equation. And that's why I think I wrote that. If the center is at the origin, and even more specifically, if the radius was 1, but the radius could be anything, you could still put r squared here. It's just going to be x squared plus y squared. So the big thing I want you to be aware of as we go through this year is if you see an equation that has both x squared and y squared in it, then you're going to be talking about a circle. And as we get into chapter 1 and we talk about different types of equations, you should recognize when you see certain equations, you should know it's a parabola, or you should know it's a line, or you should know whatever. You should know a circle is if you have both x squared and y squared in it. And when we get into trig, this little circle here with a radius of 1 is called the unit circle, and a lot of stuff that we do in trig is based around that. But super easy today is if you know that equation, I just want you to be able to answer a couple types of questions, and you might even have some time to work on your homework today, and this stuff's pretty quick to do. It's just kind of refreshing your memory. So the first one says, find the standard form of an equation that has a center of this and a radius of this. On the test, you're going to see questions just like that, where I just want to make sure that you know the equation. What's the one thing that could be tricky? What if I gave you the diameter instead of the radius? You just want to make sure you read carefully, and you would take half of it. But it's really just checking that you know the formula. Remember that in the formula, it's minus h and minus k. So the center, this is h, this is k. So I'm just going to plug that in, and that's just going to be x minus 1 squared plus y minus 2 squared equals, and it's the radius squared, so don't write 5 squared, right? Yes, it is 5 squared, but you know 5 squared is 25, so work it out. Write 25 here. And then the other thing I'm going to ask you to do with circles is if I give you the equation, that you could pull out the center and the radius. And again, it's just checking that you know that formula. When we do conics next semester, we'll get into a lot more things like graphing them, but we're not even doing that right now. And again, just be careful on not making silly mistakes. Like, if I asked you for the center on this, don't tell me that it's 4, negative 2, because the formula has that subtraction sign in it, right? So it's really like you take the opposite sign of what's in there. So what would the center of this be? Negative 4 and 2. And you can just check really quick. If you plugged a negative 4 into x minus h, that would become a positive 4. And if you plugged in a positive 2 into y minus k, it would give you minus 2. And the radius, remember that this is the radius squared, so what would the radius on this be? The square root of that is 11. What if it wasn't a perfect square? Leave it as a radical more than a decimal, right? Like, unless it asks for a decimal in in math, we care about the exact answer. So what if this said, side note here, what if it said x squared plus y squared equals 20? The center would be 0, 0. And the radius, don't type the square root of 20 in your calculator and give me a decimal, right? That's r squared, so it would be the square root of 20. But even more specifically, a better answer would be that we would simplify that radical, right? So I don't want decimals. I'd rather you leave it as a radical, but if you could break that down, you should be able to tell me that 20 is the same as the square root of 4 times the square root of 5. So the answer that I would want to see would be that would be a radius of 2 radical 5. That is an exact answer. Giving me the decimal of 4 point whatever is not the exact answer, and I'll take off something. Yeah. All right, so don't give a decimal unless it asks for a decimal. Questions about circles? That's it for section 2, right? That's why we can do 2 sections today. And we're skipping section 3, and we're skipping section 4. Because they're over like slope-intercept 1. So we're going to go into section 5. Completing the square. So in Algebra 1, you learn to solve quadratics by factoring and by the quadratic formula. And those still are valid ways, and we'll still be using those as well. In Algebra 2, I believe, is the first time that you learn completing the square. Maybe this is why I showed you completing the square. I don't know. Completing the square is required at certain times, right? If you're trying to put a quadratic in vertex form for certain conic sections, you have to know how to complete the square. When you're solving an equation, you have choices: factoring, quadratic formula, or complete the square. But there will be times in this class that you have to complete the square, and it's probably the one that people forget the most. And so that's why I just wanted to touch on that, and then when we get into chapter 1, we'll talk about it again. I started with a nice one here. Remember that the idea of completing the square is you want to make it a perfect square so that you can take the square root of both sides. That's kind of the point here. So I have a problem here, and then I kind of put some steps over here if you need them. I picked an easy one first because there's nothing in front of x squared. Remember, it gets a little more complicated if there's something in front of it. But if there's nothing there, does anybody remember what you do first? It's been a very long time. Maddie. Yeah, this is not make that a perfect square trinomial. So we kick that over to the other side. Move C over. To show that. So I have x squared plus 4x. And then I just move that 9 over to the other side. And then the big step, I always say, if you know this step, you know how to complete the square, as Maddie said. You take half of b, or you take half of the number in front of x, and you square it. That's what makes a perfect square trinomial. So half of 4 is 2, and 2 squared is 4. So that means I just put a plus 4 there. But remember, it's an equation, so how can I just add 4? Because you also have to add it to the other side. When I teach this for the first time, I always say, like, draw a line there so you know it has to be on both sides so you don't forget. But you have to add 4 to the other side to keep it balanced, or otherwise you've changed the equation. That's completing the square. Everything after that is just simplifying it and solving it. So completing the square means that we've now made this a perfect square trinomial, which means we should be able to factor that into something squared. And if you're not sure what it is, you could actually just factor it. But it's always whatever half of that middle number is. So half of 4, that should factor into x plus 2 squared. And you can check that. If you FOIL that out, you'd get x squared plus 2x plus 2x is plus 4x. And then that plus 4 at the end. So that's why we complete the square, because we want that perfect square. And then on the other side, we get 13. What do you do from there to solve it? Yeah, square root both sides. That's why we like complete the square, because now we can use the square root property. And again, just a couple little things to remind you of. It's been a while. that when you square a square root, right, they're inverses, so they cancel out. So you just get x plus 2. And you remember what you have to put over here? Yeah, when you take the square root of an equation, it could be positive or negative of the radical there. So we have to say plus or minus the square root of 13. And that's where the quadratic formula comes from. I don't know if you did that in Algebra 2 last year, but if you complete the square with this, ax squared plus bx plus c, like if you do all letters, if you complete the square and solve for x, you will get the quadratic formula. So that's where the quadratic formula comes from, is completing the square. And then the last step is just subtract 2 over. And I'm going to write it in the front. Negative 2 plus or minus the square root of 13, because that's kind of how it looks like when you do the quadratic formula. Same rules as with the circles. This is an exact answer. I don't want decimals. If this 13 could be simplified, like it was the square root of 24, I would want you to take out any perfect squares that you could in there. Memories of this? Nightmares of this? I like completing the square. There's definitely times completing the square is ugly, and maybe we should do an uglier one. What makes it ugly? When there's that number in front. What else makes it not so nice? When the middle number isn't even, because when you take half of it, you're going to get a fraction. And so we should do one of those. Questions before I go on there? So this one, the C's already moved over, but again, remember that you can't complete the square if there's a number in front of x squared. So you have to divide by that a value if it's ever than 1, right? So sometimes it's going to make it ugly. This one's not super bad here, but if I got rid of this 4, I could just go through and divide everything by 4, and now I would have x squared minus 5x. And I always leave that spot there to complete it, equals 10. So, let's have a talk here about fractions and decimals. I like fractions. I think fractions are easier to work with than decimals. I think they look nicer. I'm a way bigger fan of fractions than decimals. Does that mean you can't use decimals in here? No. But make sure if you're using decimals, you give me exact answers, and you're like decimals don't have to stop. If it's like a repeating decimal, a fraction is a way better answer, right? I think with completing the square, doing fractions here is much easier than decimals. I think that people use decimals more because the calculator automatically does decimals, and so you just stick with the calculator. The reason I like fractions is I can do the fractions without a calculator much easier than I can do with decimals. Let me show you this for a minute, and then see if I can get you to jump on board the fraction bandwagon here. So, half of 5, that's not hard to do as a decimal either, 2.5. But as a fraction, to take half of a number, you just put it over 2. Do you agree with that? So half of 5, yes, it's negative 5, but when I square it, it's going to all be positive. So half of 5, I'm going to put down here, is 5 halves. And again, 2.5 isn't a terrible one, but to square 2.5, probably, maybe you don't know what 2.5 squared is off the top of your head, but with fractions, how do you square a fraction? You just square the top and you square the bottom. I can do that without a calculator. So if I take half of this and I square it, it's just going to be adding 25 over 4. Yes? So on this side, I'm going to add plus 25 over 4. Also, your calculator does fractions, and it'll give you answers in fractions, and it'll even give you answers like this if you put the button that makes it give you improper fraction. So if you really want to use your calculator and feel like you want to check your answers especially, and you don't know how to use those buttons, ask me, and I'll show you that your calculator will give you answers like this. Improper answers. Okay, with me so far? Be careful on this one. It's a sign of the middle number, so that has to be x minus in there. And what's going to go right there? Yeah, half of that middle number, which was 5. Now over here looks a little ugly. Do it with your calculator. You can use a fraction button. You can make it change to an improper fraction. But just to kind of remind you that fractions aren't the worst thing in the whole world, if you were doing this without a calculator, you would have to get a common denominator, and that would just be 4. So what would the top become? That would become 40 over 4. So 40 plus 25 would be 65 over 4. And again, I know you can't see this, but I'm just going to tell you that, like, the fraction button on my calculators are right there, and if you hit second that fraction button, it'll change it from a mixed number, because I know that's what most calculators automatically do, is mixed numbers, but it'll change it to that 65 over 4 if you don't want to do that yourself. Here's another reason I like fractions. I feel like the answer looks so much better when we simplify this, when we solve it, than with decimals. Decimals under a radical aren't really what we want. It's not really a nice thing to have a decimal under a fraction. I mean, under a radical. So if I square root both sides, I'm going to write up here so that'll stay there. I get x minus 5/2 equals plus or minus. And what's really nice also, when you take the square root of a fraction, you can just take the square root of the top and the square root of the bottom. Square root of 65 is not a nice number, so we're just going to leave that as a square root of 65. But what is the square root of 4? 2. Which means when I add that over, I actually even have a common denominator if you wanted to put it together, and it would match so nicely. But we could say that that's 5/2 plus or minus the square root of 65/2, which is a perfect answer. Or if you really want, you can put it all together just like you would with the quadratic formula, right? If you did the quadratic formula, you would get that one big fraction answer. But both are okay. So don't be afraid of fractions. I think fractions are easier to work with than decimals. If I was using decimals there, I would have gotten a calculator to like verify, because I'm not as confident in my multiplying and squaring decimals as I am with fractions. Questions about that? That's about as ugly as complete the square gets, when you have to divide and you have something that's not even. Which means when we get to quadratics, would this be one I would probably choose to complete the square on? No. But sometimes you have to complete the square with other things. Questions about that? So this is all one assignment. So if it was me, I would do it all on one page, but you don't have to. Here's some other housekeeping things. If you write really small, because you turn your homework in all on the same day, let's say last night's homework, you have still half a sheet of paper left, and you want to just draw a line and start the next assignment, I'm okay with that. All I want to know is I just want to be able to see it and find it. So I've had kids in the past that write super small and fit a whole chapter homework on 2 sheets of paper. I write big, so that's crazy to me. But the fact that you don't turn it in every day, if you only use the front side and you have all this room left and you want to use the same piece of paper or line, label this where it starts, that's fine. So just kind of some things that you want to conserve paper that you're welcome to do. This is P2, which is page 22 and 23. 41 through 48 all. Those are all circle ones, so they're going to be really quick to do. And then 62. And then page 50, there's 4 problems there. I believe all 4 say solve by completing the square. So those are going to take a little bit more time. But even with try time, we have some time to work today. So start on these so that if you have questions, you can ask me. 16, 17, yes, 17's done. 17's good. I really made copies of your assignment sheet, and I don't know where they are. So I'm going to search for that while you work.